Now we are going to review some Snmp misconceptions. The first misconception that we are going to talk about is the idea that the manager is the server and the agents are clients. This may come from the fact that we are actually running this manager in a device that we usually refer to as a server, a computer system that we call a server. This will be false because the manager is actually the Snmp client, whereas each agent that is running on remote devices is the Snmp server. This is why when configuring agents within Cisco devices, we use the command snmp server. The second misconception will be the idea that a network management system, or NMS, only runs Snmp software. That will be false because most of the times we will be running other services within our NMS, for instance a syslog server, some automation tool, for instance Ansible, a NetFlow or SFlow service, and sometimes even a AAA server. The next Snmp misconception comes from really old tutorials and old documentation that can be found online, that there are only these Snmp operations: get request, get next request, get bulk request, get response, set request, and traps. This will be false, as since Snmp version 2 we have also inform request, and since Snmp version 2 the get response BPDU was renamed as just the response BPDU. Next misconception will be that a particular hardware device can be managed through a specific single MIB. Let's say, for instance, that we wanted to manage Catalyst 9200 through Snmp, so we may have the idea that we need a particular 9200 MIB. That will be false. We actually need dozens of MIBs in order to manage a particular device, and many of these MIBs can actually be used to manage other hardware devices. Just a note here, if we wanted to locate all the MIBs available for a particular hardware platform for Cisco, all the thing that we have to look for is Cisco MIBs, and we will be redirected to this feature navigator. Particularly, we are going to use the MIB option within the menu. Then we select the iOS, and then we are going to go for platform. We can look, for instance, for Catalyst 9200. Then we have to select the particular iOS XE version, and then we will be redirected to all the MIBs that are available for this hardware platform. We are offered the version 1 and version 2 of each MIB. And the last misconception that we are going to talk about may come if we are still learning new tools such as NETCONF and Yang. We may end up with the idea that Yang files are easy to read, whereas MIB files are hard to understand. This will be false, since both files are human readable. They offer the same degree of challenge in order to be read. They are just written in different languages. So if you're familiar with Yang and ASN.1, you will be able to read them both.